Okay, students, here we are at 7.1 and how to solve a linear system by graphing. First thing is you're typically given two lines or two equations of a line. You should identify where those two lines end up crossing at a place where you can measure on the graph. I'm going to pretend that this crosses at -1 and 2, and therefore I highlighted that area in purple and put the point -2, -1, where this is x and this is the y of that line, where the two meet. So this is solve a linear system by graphing. So the easiest way to do this is to see if the first one, which is our red line, 3x plus 2y is equal to 4. All I need to do is solve this by putting the x number in here and this y number in here. And if this side, if the variable side equals to 4, then that's true. And let's put on here 3 times 2 plus 2 times a -1 should equal to 4. Let me squeeze that in there. So 3 times 2 is 6 plus a -2 should equal to 4. This could also be written 6 minus 2 is equal to 4, and 4 is equal to 4. So you know that this point right here is a solution to this line. Now the question is it a solution for both lines? So you'd have to repeat the same exact thing you did above in this formula. Now you need to do it in the one in green. So let's do that right now, where we go -x, which in this case is 2, making that a -2, plus 3 times y, which is a -1, should equal 5. Let's see. 3 times a -1 is a -3, minus 2, 5. In this case, a -2. Whoa, what is this? A -2. Did I do something wrong? Okay, so I copied this wrong. This is a -5 here. Makes this a -5, makes this a -5. Let me go back to my black coloring so I can remember what's going on, which makes this -2 plus a -3 gives me a -5 is equal to a -5. And if this is equal to this, that means that this point in purple is actually the solution for both lines, meaning that this is where they cross. So the solution of a line means where the two lines have the same point or where they cross. Hope this helps. Okay, here's our second example. In this case, they gave us two equations, and they asked us to solve the linear system. They asked us to do it graphically. So I set up a graph here. But in order to set up a graph and make a line graph, I have to convert both of these into the y is equal to mx plus b format in order for me to graph that. So I'm going to set it up right now. So I just extended my board a little bit. I'm going to subtract -3x and -3x. And what this will give me now is y is equal to a -3x plus 11. And that's for the first one. And now I have a -x on here, a -x over here. Gives me a -2y. It is equal to 6 minus x divided by -2, divide this whole side by -2, gives me y is equal to 3 minus 1/2 x. Now these are my two lines. So here we go again. Now I've circled the solution or the slope-intercept form for one of the problems in purple and the other one in red. What you're going to do is we're going to graph this. Of course, we go to our y-intercept, which is 11. If we look up here, we know that 11 is 1, 2, 3, 4, 5, 6, 7. Whoops. So here we found the point of the y-intercept, which in this case was 11. And then you go down, the rise is rise over run, a -3, 1, 2, 3, run 1. Here's where this goes down. And we just make a line that connects that to that. Now, We're going to graph the other line now, and the y-intercept on that one is 3, and I'm going to turn my color to red because we have two different colored lines. Here's my y-intercept, it's 3. Put a red dot there. The rise over the run is a -1, so the rise is a -1 over 2, 1, 2. So let me do that again, -1, 1, 2. And here's this line. And now I'm going to get to draw the line, and I'm not going to do a good job because I don't have graph paper. But there's the place. I'm thinking that the place where these two intercept is, so the place where they intercept at this point, what I could see is probably a 4, -1. Yes, there were some changes because I found out where it actually intersected. And now I got to prove that algebraically by sticking this 4 into where the x's are and this -1 into the y is at. For both of these equations, this one and this one here. So here I am, I rewrote this. If you're wondering where this -1 came from, I'm going to highlight it right now. This -1 came from this one right here. This -1 came from that same place right there. And the 4 in here, this x came from here. Here's my 4. Here's my 4. And that way you know where these all came from. So now I'm just going to do regular old algebra multiplication, and this gives me a -12 plus 11, which is equal to a -1 is equal to a -1, and this point is the solution for that. I'm going to do the same thing here. I'm going to go 4 times 1/2, which is this gives me a 3 minus 4 times 1/2 goes 4 to 2.